We are starting with a new chapter, the S block elements. It's chapter number 10, and let's begin. So, as we know, the periodic table is divided into four blocks based on the orbital the outermost electron gets added to. And that using that, we have S, P, D, and F block elements. Right. So, in this chapter, we will be focusing on this particular block. So electrons, in this case, the electrons are going to be added to the outermost s orbital. And you have two types, two groups, because there are the maximum number of electrons that can be added to the s orbital is two. And they are alkali metals and alkaline earth metals. Now, the reason we call lithium, sodium, potassium, rubidium, cesium, and francium as group 1 and alkali metals is because they form hydroxides when they react with water, and hydroxides are alkaline in nature. Now, alkaline earth metals are called so because um, the oxides and the hydroxides of these metals are alkaline, like in this case. But in this case, the oxides of the alkaline earth metals are actually found in the Earth's crust, or rather, the alkaline earth metals are found as their oxides in the Earth's crust, and that's why we call them alkaline earth metals. Now, this consists of lithium, as I told you, the metals, the group 1 elements are lithium, sodium, potassium, rubidium, cesium, and francium. On the other hand, alkaline earth metals are beryllium, magnesium, calcium, strontium, barium, and radium. Okay, so these are the elements of the respective groups. Now, the abundance. Abundance as in how much, how much is available, right? In an alkali metals, sodium and potassium are abundant. These two are abundant. And however, lithium, rubidium, and cesium are quite low. Francium is highly radioactive and it's most stable. The most stable isotope of francium has a half-life of just 20 minutes, if I'm not 21 minutes, and that is the longest lived isotope. So that's about 223 francium that has the half-life of 21 minutes. So yeah, you can assume how abundant it is. Alkaline earth metals, on the other hand, you have calcium, magnesium. Both of these are the fifth and the sixth most abundant element in the Earth's crust. Strontium, barium, lower abundance. Beryllium is quite rare, and radium is the rarest. Not only that, radium is just like 10 to the power minus 10% of the igneous rock. So that's how low it is in the Earth's crust. The next is the general electronic configuration, noble gas, as in the noble gas previous one. So before potassium, whatever the noble gas is, that followed by NS1. The N refers to the period, the number of the period number. And in case of alkaline earth metals, they have a full s orbitals, NS2. The anomalous. So in this chapter, you'll be learning about these two topics. That is the anomalous behavior and the biological importance of certain elements. So if I talk about anomalous behavior, it is noticed that lithium showed similarity in properties to that of the adjacent group. So, for example, lithium shows similarity with magnesium. Okay, beryllium will show it with aluminium, and that particular thing is called as diagonal relationship. So you'll or rather we'll be learning about that in detail at a later point in this chapter. Not only that, biological importance of certain elements is that if you there's sometimes when we start feeling really giddy, and we notice we notice that okay, we don't feel too great, and it's immediately told, like, drink some water, and if it's really bad, you drink some electrolytes. So the electrolytes are very important because they are involved in the transferring messages through the nerve cells. Okay, so we'll be learning about how important few elements are, and we'll realize how important they are in our body more than ever before. So we'll continue. So in this chapter, we'll be talking about the alkali metals, alkaline earth metals, the physical properties, the chemical properties, anomalous behavior, and the biological importance of the few elements. And we'll also be talking about some compounds of these groups. But before I finish this video, I would suggest you go back to the third chapter, chapter number 3, where you learned about the various physical properties, what they are, because the moment you're clear as to what those physical properties are and what they mean, and how we justify across the period down the group, you'd be able to easily apply the same set of rules to these as well. So yeah, so in the next video, we'll be continuing with the physical properties of alkali metals as well as alkaline earth metals.